Welcome back. I hope you enjoyed doing the labs, and I hope you've got your head around some of the basic select syntax now and you're ready to move on. So for this module, we're going to look at some slightly more sophisticated examples of using select, and Jeff is the expert. So Jeff, why don't you tell us a little bit about using the select statement?
Thank you. So we're extending what we've done. So we've done some select already. Taking it a bit further, we're going to look at removing duplicates from our record set. And we saw there was some before where we got the same sizes and they were repeated in there. We've talked about order by. We're going to have a look at using that in practice and how we can sort our results. And then a few more things we'll work with a bit more complex with sorted results, and we'll also look at how we can filter our data. So at the moment we're finding every single row, and we want to reduce that down and say, actually, no, specific rows we're interested in that we want to find and how we can do that.
Okay, great.
So to start off with removing duplicates, a lot of the data we've been showing a few columns, but if we'd just shown one column and there'd been lots of size 58 or medium, and that would have been repeated. So every single row that we've got will be returned. So if I've got 58 rows and they all have the same piece of information, I'm going to get 58 entries with that same piece of information. So in here we've got a list of colours for our products. Now we're going to get one row per every single item I've got in there. So although I've got 2 blues, 2 yellows, I'm getting 1 per row. So I don't really want that. I want to know what colours are we producing.
So this is one you're getting one for each product. It's not one for each colour, it's one for each product.
No, every single product's got its own row, yeah.
Yeah, so you're getting one row back for every product, and that means you're going to have multiple colours because some products are the same colour. Now you've got select all, but you haven't put all in the query.
No, in many cases actually, people who write SQL are somewhat lazy.
Okay.
And we have a tendency to leave out unnecessary words. In fact, select all you will practically never see written because everyone understands that you want, if you don't define anything else, you want all of the rows. So we don't tend to write select all. You mentioned as when we're doing aliases, it's good practice to use that because if we leave it out, it looks very, very similar to a comma being there, and that means something completely different. So we do tend to type as, although we don't need it. All, I'm trying to think, I don't think I've ever seen anyone write it in all seriousness because you don't have to.
Okay.
And as we get later on, you see there's some things actually where we have optional, we'll talk about, you could put this word in, or sometimes you can put different words in, it does the same thing. Because it's quite a fluid language, it's quite reasonable with its programmers. A lot of procedural languages are very, very strict. This is not. We can actually do things in a slightly different ways. It doesn't make any difference to what the actual engine does.
So select all, it's going to bring, in this case, it's going to bring back a row for every product, and that means in my result set, if I'm only looking at the colour, I still get a row for each product. So if I've got multiple products with the same colour, I get multiple colours.
You get the same number of rows as you have products.
Okay.
So to get rid of those excess ones, because I only want to know what colours do we sell, then we can use that keyword distinct. So it's an alternative to all, but actually, as we said, we don't really type all. So if we put the word select distinct in, we get distinct colours in there. Now, if I had another column, though, we're talking about distinct in terms of everything I've typed in. So if I had distinct colour, comma, size, then it would be distinct colour size combinations.
So it's distinct at the row level, not at the individual column.
That's right, yeah, because otherwise how would it decide which colour row to display? So for blue, would it know to do the medium, the large, small? It doesn't understand. So it displays all of the distinct rows.
Okay.
And then we'll have a look at sorting results. Now, we've mentioned this before, quite often it appears that you have the correct order. Normally, the order they come out will be the order of the primary key. So if I've got a product ID, normally they'll be in product ID order. But we can't guarantee that. And it may be that actually if you delete some products from earlier in the numbers and later they get reinserted into your database, they might actually be later in the result set. So although it appears correct, we can't guarantee correctness. So we can use order by. By default, another word that you don't see very much is ASC, which is ascending. So typically our order by would go ascending, so from 0 up to 100.
So that's the default.
That's the default, and we don't tend to type it because we don't need to type it, and you expect it to go. You expect things to go A to Z.
Right.
But if you want them to go Z to A, or Z to A, wherever we are in the world, then we can do DESC for descending. So here we're looking at saying, I would like the category, I'd like the product name, and I would like to order it by category ascending, and then by price descending. So it would only do it by price if you've already ordered it by category. So it's ordered by category first, and then where we've got the same category, then order by price descending.
Okay.
So one ascending, one descending, we can do that. The other thing we've got in there is there's aliases. So we've got a category alias. Remember, the order things are done. We can use that alias in order by because it's been defined. The order by happens after the select.
So select is the second last thing done. So the order by knows the aliases I've used in the select.
Yes.
Right,
so
okay.
we're fine to use it. We could equally do order by product category. We don't have to use an alias all the time.
So
sometimes you do,
right.
though. There are times when it will completely override it, but it's one of those, as I said before, if you make the mistake, you kind of get used to it and you think, okay, well, I haven't used an alias or I have used an alias, and you switch backwards and forwards. So now we're going to have a look at saying, I don't want all of the results. I'm interested in our most expensive products.
Okay.
I don't want 1,000 products.
That's very like you to be be interested in the expensive products.
Says the person with the new Surface laptop. So I'm only interested in the top most, say, 5, 10 most expensive products we do. And we could return to a client application all of them sorted, and they could then just display the first 5 rows they get. And that's pretty straightforward for any client application to do. But I've just transferred, potentially over the internet, or at least from a server to a client, potentially hundreds of thousands of products. It could be vast numbers of products. I might be a multinational supermarket. So I don't want to do that. I want to limit the amount of information I'm sending. So I'm going to say I only want the top 10, or we could be a bit more than that. We could say top so many % as well. Now we must use order by here because we don't have a guaranteed order. So we need to make sure I know what top 10 am I displaying. So it must be the top 10 sales price, for example. Or
So if it's unordered, presumably it just returns the first 10 rows that it throws out if you've specified top 10.
If you do top 10 and don't do order by, I think it's going to throw an error, actually.
Okay.
But you need to make sure they're in order to do this. Now, the other thing you might want, so I said you could have the top 10, you could have the top 10% or 5% or whatever number you want. Equally, you could have with ties, because actually I may well have multiple products that are the 10th most expensive product, and there might be quite a few that have the same price. So therefore, how do I decide between them? And if we don't specify anything, we're not deciding between them, it will just display one of them. So actually with ties it's quite useful in that we leave in any equal to. So it's top 10, or if you match the value, display that one as well. Just a question for you. What about if I wanted to display the bottom 10? I don't seem to have a bottom keyword.
Well, no, but your order by would be the other way around.
So if I order by ascending, descending,
you would get the bottom 10 items. They would be in the wrong order because they'd be ordered.
They're the top 10 bottom items.
Top 10 bottom items, yes, exactly, yeah.
And here we're looking at a little bit more complex. So paging through our results is saying, well, okay, you've got the top 10, but I don't actually want the top 10. I want to have numbers 11 through 20, and then I might want numbers 21 through 30. I want to have the next set.
So this might be on like on a web page where I get the first page of results, but I want to page through and see the next page and the next page.
And then you go through, and sort of 10 or 100 at a time, we could display that. So here what we're saying is, and this is one where we've got language getting even more fluid, because in here it's saying, firstly we're going to offset so many rows. So I'm not interested in the first 10. I've already done those with our top.
So this is the number of rows I'm going to skip.
So I'm going to skip 10 rows, and that's offset. And the rows, you can see on the slide that we actually have a bracket around the S. We can say offset 1 row because that's good English, or we could say offset 10 rows because it's good English. Okay. But equally, I can say offset 10 row.
Right.
or offset 1 rows, it doesn't make
so
any
interchangeably,
difference.
it recognises row and rows as meaning the
You
same thing.
tend to type it in English as you would normally write the word in English, but if you're changing from 1 to 2, you don't bother changing it because it does the same thing. And then we get to fetch, what do I want to get? And I would like to fetch the first 10 rows after I skip 10, but equally you might say, well, isn't that the next 10 rows?
Right.
They're the same. So again,
So first and next
or
are treated as the same.
doesn't make any difference at all. So row or rows doesn't matter. First or next doesn't matter. You can use them either way around.
Okay.
It does exactly the same thing. So then we're basically saying, so skip 10 rows, fetch the next 10 rows, so I can display those next 10 entries that we were looking for before.
Right.
It's not something you do all the time, but it's something if you need to do it. Previously, we had to do sub-queries and really quite complicated queries before we had this ability. So
Right.
when it's used, it's priceless. Although often actually, you don't often want the next 10 rows. But if you do, as you said, web pages might be a good example.
You're paging,
We want to
yeah.
page through. So we'll have a look at getting rid of duplicates and sorting and those things we just talked about in the slides.
All right.
So I'm just using Visual Studio Express. Again, it's Express Edition, so it's free to download. You might be using this for developing other things as well, but we can do it in here as well. In exactly the same way that Graham set it up before, we have a connect option in here, so we can set up a new project, we can connect this up, which is this one, isn't it? And we can specify a connection string. Again, I've just called it MVA in here, and specify the logon details in there. So it's the same window basically that you used before. So to start off with, this is a query which we've already seen the sort of results we can get. So that's a list of colours, and we've got an is null in there just to display. If we've got any nulls, we can clear those out and display null. But we have got a lot of different rows in here. There's a lot of reds, there's a lot of whites, there's a lot of multis. So I don't have a list of colours. I have every single item
For each product, you've got the colour of that product is, yeah.
One row. So I've got 200, if you see at the bottom right, 295 rows. I don't have 295 different colours.
Okay.
So what then happens if we go into here and do a distinct in there, and it's just literally adding that keyword, will strip out all of those duplicates, and we now have 10 rows. So that is the different colours that I have in there. I mean, it's specific. So I've got silver and I've got silver black. So those are different things. So it is absolutely, even if someone puts a space in, which is something to watch out for actually. If someone put a space in after the word black, that's different.
That's different from black without the space.
To black without the space. They might look the same, but it is absolutely specific in there. And I've got my nuns in there as well because we've got the is null test in there as well. And that's useful because nulls they add confusion in here. It's an unknown. I always think null means unknown, so then you have to think what would happen if I put unknown values into that. So to continue on, sorry, go a bit farther. So
we've got our colour.
There. And this one we're just adding a little bit more because we want to put them in order. So always worth, if you want the output to be in order, to do an order by.
Right.
Remember, it is now just ordering them by alphanumeric order. So the null comes in the middle because it's an N.
Right.
Because it says none. So,
but in sort of classic application design here, if this were, say, countries or regions or something you were choosing from a drop-down list in a web page, for example, this is pretty much what you would do. You would want to return them in order because the way that user interface element is going to work, you're going to be able to scroll through them or type the letter to get to the value. So ordering is very important.
Well, yeah, because you expect to be able to get through to that. I mean, we're living in the United Kingdom, and it's quite useful that a lot of things jump to the United States because we're right next to it.
Yes.
So, but if we weren't, that would be annoying. Yeah. It's annoying if someone puts in Great Britain because it's miles away.
Yes.
So you have to scroll a long way. But yeah, so you expect them to be in that order, and that's what people expect. There are other ways we can get. You say, well, what if you wanted to have the most commonly used ones at the top? And we'll talk about unions and things like that. And we could have other methods, but essentially, yes, you want them to be in order. Just adding a little bit more to that. So same sort of thing in here. So we're going to do a list again. Now, what we're doing is starting to have multiple columns now. So what happens now? Notice that the black. That's displaying multiple times because we've got also the size. So in there, we now have the colour and size. So it's unique across colour and size. Now I have 68 rows. I think there were 295 products. We had 10 different colours, but we've got 68 different colour and size combinations.
So it's the distinct combinations of all of the columns that you've selected.
Exactly, yeah. So that they all look like black at the moment. If I scroll down through that, you'll see that we've got blues and the greys and so on. So it's combinations of those two. It can't decide which one to display. It would always display all of those in there. Now, the top we talked about, so I'm not interested in all of them. So I only want the top 100. Again, must do the order by to make sure we want the top, so we're going to do descending order in there. So that gives me the most expensive products in here. Now, we might also want to fetch the next set. So what we're going to do in here is to say, initially, we're going to use this offset. Now, I know that I'm going to use the offset to select each 10 in the row.
Right.
Now, it makes it much easier if we set up the same code for each block of 10. So the first block of 10, you think, well, yeah, but that's not doing that. You just want top 10. But if I'm passing values from a client, it's a lot easier if I'm passing them into the same place each time.
So if I know I'm going to page, rather than just selecting the top and top 10, it might be better to use the offset in this case because I'm going to want the second page and the third page
exactly.
and so on.
And in most cases, actually, in terms of performance, people say, well, but wouldn't that affect performance or something? A lot of the time, SQL Server is pretty clever about what it does. So it's not actually, this language we see is something that it then compiles as the instructions of what it needs to do. Those are not the same thing. So quite often it will do exactly the same thing with the top, or with the offset, with an offset of 0, it would actually run the same.
Okay.
That hidden magical code underneath that we can't, with the matrix, if you like, that we can't understand, is probably going to be exactly the same in whatever it runs. So we've got an offset of 0 rows, so that basically means the top.
Right.
Then fetching the next 10 rows only in there. So you need to put the only row, we could put rows of rows, fetch could be then next, or it could be first, wouldn't make any difference. This is, you could say, well, really, that's the first. This hasn't been mentioned, I don't think, actually. We've got a lot of these green lines with 2 dashes at the start. Now, I'm highlighting that one there, but what happens if I...
Well, we are going to come on to that later on in the course, but these are just comments. These, like in any programming language, typically there's a way of annotating your code with comments, and that's one of the ways that we have in Transact SQL of indicating this line is not to be executed, this is just a comment.
Yeah, so I highlighted that by mistake, but I can just run it. It won't make any difference. Okay, so now we've got in here, that's the first 10 rows in there. Now notice these ones are ordering by product number, so it's not by list price in this situation, so that's why they're not in list price order. It's actually showing the first 10 products by product number. If we want to display the next 10 products in here, then we're just going to go and set our offset for 10 rows. Okay, so we can go through and then...
And you switch to first this time, but it doesn't matter. First means the same as next.
And even though I'm actually selecting the next 10 rows, so I've actually done
deliberately
the wrong way around. And actually, I've also changed the 10 to row, even though it's a singular or plural. It doesn't make any difference. You can just run it either way around. So basically, it's going to go through 10 at a time, finding those, and then so if we're not really doing things where we're passing values into functions and stored procedures on this course, but ultimately it may be that we actually pass a value from a client into there, and this becomes a lot simpler because actually all I'm doing is passing a value into where we have a 0 here, or where we have a 10 here. So I can drop a value in there and then decide which 10 I'm after, and actually I could display another value, which would be how many I'm interested in. But if I'm always interested in 10, it would be really simple to drop a value in there And so we can use a 0, we can use a 10.
Reuse the same code, just depending on which page we want to go to. We have a different value for the...
Exactly, yeah. And that would be really simple for a programmer of a sort of website or something to drop that value in for which one they want. Filtering then. So we've talked about the where clause. There's lots of different things we can put in the where clause. So the most straightforward being equals. So we can say where colour equals red, for example.
Bring me back all the red products.
Yeah,
is what we're saying.
So it's matching that exactly. We can also do greater than, and we could do less than. So obviously we can do where value greater than 100. We can also, to add into that, we can do greater than equal to. So if we want to find 100, then we're looking at greater than equal to. If we just do greater than, it will find the smallest increment greater than, so 100.000001 is greater than 100, but it wouldn't find 100. 100 has to be greater than or equal to. So we use that quite a lot, use greater than or equal to. The next one in, we might be looking for a list of values, so we can say colour in, and then in a bracketed list do red, blue, green, and we can define a list of different ones I'm interested in. You could... And I'm going to jump down a little bit down here, have an or as well. So I'll come back to that because we could say, instead of using in, we could use or. So I'll come back to
equals red or equals, okay, I see.
Yeah. Between, now if I say between 100 and 200, the only slight confusion that might be there is, does that include 100 and 200? So if we're saying between, it's slightly confusing because it's what about the absolute values? So we're actually going to say a greater than equal to and a less than equal to. We're going to say in between.
So it's inclusive. If I say between 100 and 200 and something is 100, that will be returned.
That's in the set. Now, we've talked about numbers. It's quite easy to find something that's in the hundreds. Because something in the hundreds is between 100 and 199. Or less than 200 maybe even. You can specify a range. But what about with text strings? We don't have that similar ability. What we have is that it begins with an A.
Right.
Or it begins with AZE, or it has a bit of a text string that we're interested in. So we can do a simple like, which basically says I'm setting this up to say accept some wildcards. So I can say like A, and we have a wildcard which is a percentage symbol, and that says anything after the A is fine. And equally, nothing after the A is fine as well. It would find an A, and it would find an A with any number of different characters after it.
So it's a bit like on the file system, if you're looking at folder names, you could use the star as an asterisk, as a placeholder. In SQL Server, the equivalent wildcard for any character isn't an asterisk, which we've seen used already to say all rows, but actually when I'm using like, it's a percentage symbol.
Yes. So and actually, if anyone came from Access SQL, Microsoft Access, they actually did use a percentage symbol. Sorry, an asterisk. Yeah. So that sort of A star would have meant that, but here we use a percentage symbol. There are other ones as well. We could use an underscore as well, because it may be that actually within that like, we don't want to find just A's. We want to find an A followed by 2 digits and then a Z.
Right.
So we could put in a percentage symbol. If we put A%Z, that would be begins with A, ends with Z. And I don't care what's in between. Okay. And there could be nothing in between. That would be fine. But I want 2 digits, so I actually can use an underscore in there, and that says any digit is fine. I don't care what it is, but there has to be something there. So A __ Z says A, 2 digits.
2 digits of any sort.
Yeah. And it could be numbers, could be text, could be whatever. A, 2 things, and then a Z. And we can actually mix and match. If you've got complex codes, then actually those codes, you can find bits of them. It could be the product category is somewhere in there. It could be the car registration number. The year of the registration might be somewhere in there.
So if it's a pattern of some, you can describe that.
We can find bits using wildcards in that way with like. And we're going to use when multiple things need to be true. So colour is red, or colour equals red rather, and size equals 58. And we'd find both of those have to be true to return that set. And then almost, well, not the opposite of that, but another technique would be or. It could be either one could be true. Now, if I come back to what we said about in, so in is a list of red, blue, green in brackets, or we could do as an alternative. So we could say color equals red. Now you'll see why in is so useful, because color equals red, and then we can't just put or blue. We have to put or color equals blue or color equals green. So there's a lot more typing.
Right.
Most SQL programmers are lazy, so they will use in, and then it's much easier. And then if you combine the ors and the ands, we might say, I would like to find a size of large in red or blue.
So color equals red.
And then we could say, what would if I do color equals red or color equals blue and size equals large? But the problem is that the or, I have to put the ands on each side of the or. So I have to go in there and say size equals large and color equals red, or size equals large and color equals blue.
Okay, so isn't there another way I could shortcut that?
We could shortcut it. I mean, ins would be ideal for that again, because you could do in that and that.
Well, couldn't I use parentheses? Couldn't I say color equals...
Exactly like mathematics, in exactly the same way as maths works, because if everyone remembers their bod maths, the order of things, the simple way of making sure what you're doing is correct is to use brackets. So you say, okay, work out that side of the brackets, and then work out that side of the brackets. So we can say, work out this, and work out that, or work out this, or work out that.
Right.
And then in the bracket, inside the bracket is done first, basically.
Right.
So there's different techniques. Just make sure, always when you're doing these things, making sure that you've got records that you would expect to get, because it's quite easy to do that and say, oh, I'll just put in an or at the end, and actually you get records that you're not interested in.
To run them against test data to make sure that you're getting expected results.
Okay. Does that look right? And then not, it's quite simple. We get the opposite of what we're doing. So we can say not in, and this one's not in a list, but remembering our nulls, which won't occur in either list.
Right.
Because they're unknown, maybe they do.
Right, okay, I see.
It's quite possible that, although however unlikely it may be,
yes,
it is possible that actually your manager is Queen Elizabeth. It's unlikely, but possible. So therefore it won't occur in either the in list or the not in list, because it's an unknown value.
Okay.
So let's have a look at filtering with predicates. I'm going to open up a separate query I have in here. So to start off with, very simple information in here, where we're going to do a simple where product model ID equals 6. So it's really simple. I'm just looking for product model 6 within my database. And I just need to reconnect, so I'm using another query. Just take a second. And I've done I do this a lot, querying master. Yeah. I've just got a new connection, it's gone back to master again. Right, there we go, we're on Adventure XLT. And there is all my products which have a model ID of 6. We could change that. Maybe this is somewhat irrelevant, but if we wanted to look with a product model of greater than 6, it was 11 rows got returned before. And if I run it with the greater than, then we could do 264 rows that have a product model ID greater than 6. Okay. So we can use greater than, equal to, less than, all those different filters.
And you could use greater than or less than to effectively mean not equal to.
We could do greater than, less than, yeah, or we could do that it's not equal to, because we can do greater than, less than symbols. Do you mean?
Yes, that's what I mean. Do less than, greater than. It's not equal to. Yeah.
Sorry, I thought what you meant is to say where product model ID greater than 6.
Or no.
Yeah. Okay. Yeah. We can do the greater than, less than symbols in there, and then it will find the ones that are not 6 in here. If I can highlight things properly. Okay. So now we have 284 rows in here. Now using wildcards. So we're looking at things which have a product number. So if I display all of them in here, again, the highlightability is really useful because you can just pick the bits of code you want to run within here. So that's why it's useful to use client tools. And you see we've got some of them beginning FR, others beginning HL, SO, and so on in here. So if I add the where, if I don't put like, let's just start out with this being equal to, then I am literally looking for those values, and I would expect to get none. Okay, so nothing gets returned. Because you might have products which have
a percentage sign in the name.
It's a good idea. Again, it's a bit more database design, but if at all you have any influence, it's a good idea to try and avoid that,
right?
If at all possible, because it will cause you a few headaches. You have to use odd escape characters and so on in here to search for things that have. Oh, caps lock was already on. My caps lock was already on, so I just like in lowercase. Does that matter?
No, it won't do. Transact SQL itself is not a case-sensitive language. The convention is to uppercase keywords. You might want to be careful with the values that you're searching for, because depending on how the database is configured, strings might be case-sensitive or not case-sensitive. Or case-insensitive, I guess. That's a setting at the database level that says we should compare strings, using case-sensitivity or not case-sensitivity. But the keywords themselves, SQL Server doesn't care. It just knows that like is like and select is select.
Yeah. So I meant to type like, and I hit a caps lock, forgetting I'd already typed caps lock last time I did it.
So
I'll run it with that. In fact, if you look at my SQL code, there's lots of instances of lowercase, which should technically be upper. Right. So in here now we're filtering this. So we've got FR, it begins with FR. So all of those begin FR. They could have anything after it. Could be any sort of data, any number of characters, or it could actually just be an FR.
Okay.
So anything is allowed after that. If I wanted to do ending with something as well, we could do it the other way around. So we could, it's where we put our percentage symbol that's relevant. So if I want to find things ending 58 in here, then we could do 58 at the end, and we can run that. And they now end 58. And if we wanted to do ones that contain something, so if I said contains an R, now it may be it's the beginning, and maybe it's the end. And I've still got caps lock on. Now, it doesn't matter, beginning, end, middle, it could be anywhere in there, because that percent can be nothing as well. So all the ones that have an R, you see there's an R at the end there.
Yeah.
And equally an R, and there's a couple of R's in the middle there. All of those fine. Could be anywhere within it. So containing essentially is to do that. Okay. Now we're going to go with a bit more complexity in here. So we're going to use some underscores, which means any number of any character, but in that place. So I'm starting with FR. So it begins FR. That's absolutely. Then it has a dash. Then it has anything. Okay, so we've got in here.
The dash is a literal in this case.
That's literally a dash, and then an underscore says I can have anything after that. Now, what I then want, I don't want any letters to be found, because the codes I'm interested in are very specific. It has to be a number. It can be any number, so I've done 0 to 9. If I wanted it to begin there with a 5, I could do 0 to 5 as well, or sorry, not begin with up to a 5, but be 0 to 5, or any range you're interested in, we can specify in there. Then we've got 2 digits, then anything, then a dash, then 2 more digits. So we can be quite prescriptive about what it actually contains, because a lot of these codes, and we've seen the 58, that's probably the size, that actually it may be that your database doesn't contain these things as separate columns. It might be that a code actually contains the color and the size, and
so you need to search on that. Yeah.
Yep. Again, it'd be nice to speak to the database design people to strip that out as an individual piece of information, but we can't always do that. Okay, so now we're filtering, and let me just display the product number rather than the name. So it's product number, yeah. And then we'll see. As it gets more complex, you can actually see it takes a little bit longer. The queries might take a little bit longer to run, but we've got fr dash in here, and we're specifying exactly.
Just fr dash any character.
Something, because we've got an R next, in that one. So any character, then 2 digits, the 9 and the 2, that's fine. Then any character, then a dash, then 2 digits.
Right. So it's very specific. And I guess you could use this if you were looking for email addresses. You'd find, any contact detail that is a string, an @ symbol, a string, a dot, and then anything.
And maybe you're looking for dots.
Specifically .co.uk or .com or whatever.
Or, you can specify exactly that. And in here, I'm not interested in a product which is called free range chicken, which just happens to begin FR. I'm interested in this specific structure. Means I know what I'm getting back. I know I'm going to get all the sizes back of those, but I'm not going to get other products which just happen to begin FR.
Okay, good.
In there, so you can. This is something you can spend ages if people ask for a really specific thing. Then you're using your underscores, because I haven't used a wildcard with a % there either. So you could add to that, which would be containing this or beginning with this. And you can get more and more prescriptive.
All right, what about nulls?
Let's move on to we've talked about nulls already a bit. So here we're looking at our no. In fact, I think you mentioned this specifically before, that we have no end date in here. So we're going to do an is not null. So we're not going to put in here that it's not equal to null, because if you remember, logically that doesn't work. So what you're saying is not equal to
something we don't know.
Something, and we don't know what it is, so we can't say it's not. It might be equal to it. It might be very unlikely, but it might be the case. So in here, we shouldn't be doing a not equal to null in here.
And it says there aren't any where the cell end is not null, which we know is not true.
Yeah, so if we go in there and change that to is not, then we've got records. So it's important to do that. I mean, that's an example again where we're checking the result sets, because we did, it works. As far as we're concerned, it said, there's your results. There are none. And you could present that to a customer or another person in your company, and there you go. And
the data's not right.
And it's not right. Now we're going to do a range search in here. Now, trying with dates to, in here, we could in here put different date formats, as we've mentioned. So I've used the standard, the ISO standard for dates, which is that we're going to put the year first, then the month, then the day.
Right.
In these. If I put in here 2006/31/12, it would still work, because it understands it. So when you were talking about conversion of dates, trying to make sure you know what you're presenting in here, and where we could have potential for confusion, i.e. any day before 12 or earlier, then you could have potential for confusion. And also being aware that if I'd accidentally typed a 1 after the 3, meaning I'm interested in the third as a month, but actually drop a 1 in there, then suddenly it's going to look at it and think,
the day of the month, or the
other
way around.
You've done the wrong way around.
So it tries to be helpful, and sometimes that in itself is not helpful.
It does. Sometimes when you want an error, you don't get one. So in here, now I'm searching for a range of products. So I've got products with a sell end date between 2006 1/1 and 2006. So I've got 29 products as opposed to the 285. Right. I think that we have total. So we've got between ranges in here. So it is including. So I will have the 31st to the 12th. I will have the 1st of January. Right. So I'm going to have the whole range in there if we sold much on the 1st of January or the 31st of 12th. Now we're going to have a look at a list. Now remember, what we could do with a list is we could say where product ID equals 5, or product ID equals 6, or product ID equals 7.
Right.
That's an awful lot of typing compared to in and then 5, 6, 7. And we could put any number of things in here. We could put from one thing to 1,000 things, if you want to type 1,000 things, and they're just a comma-separated list, and then all of those items will appear as ors, essentially, this, or this, or this, or this.
Okay.
Without having to type in all the ors. So we can do that one now. We've got 5, 6s, and 7s in there if I scroll down. Notice the order as well, actually. So we said about order by. Here's the sort of first example where it's done it wrong. There's not a logical order. I might want them ordered by a category ID in here. So the product category ID is the key thing I'm interested in. Well, it started with 6s, then we had some 5s, then we had some more 6s, then we got some 7s. So it may be that when I first created this query, they were actually in order, the order I wanted. But ultimately, data's changed, things move around, and it.
So we don't want to rely on that order. If you need them in order, use an order by.
Always use an order by, yeah. So now we're going to say multiple clauses. So we're going to do an and. Okay, so they have to be in there. Now, remember the in being quite useful here because we've effectively bracketed that as a search on one side of it. So we're going to say they can be 5, 6, 7, and the cell end date is null. We're going to find those. But if we'd used ORs, we would have to make sure that in every segment of the OR, we'd also search for cell end date being null. So that's where
have some sort of system
or
of
use brackets, yeah. So now we've got all of those with a certain date of null, but it's still finding 5, 6s and 7s in here. Now, here actually, there's an example where it's worked. It's in the right order, 5, 6, 7. So I'm happy with that. Send that out to someone. There's your code.
And then later on, it might not come out in the right order.
Falls over, yeah. Now we're doing wildcards again. So we're going to say where product number is like or product category. So now we're saying they don't have to be 5, 6, or 7 as long as they begin FR in the product number. So we can say...
Oh, yeah, okay. So we're saying...
So they can be 5, 6, 7, but they don't have to be. One of those two
so
conditions
either they're
can be
like
true.
FR or they're in 5, 6, and 7.
Or both.
Yeah, or both. Yeah.
So yeah. So you'll find ones in here which begin FR, and you'll find ones in here which do not begin FR, but they'll be in 5, category 6, ID 5, 6, or 7. And you'll find ones in here which probably, I'm not going to search too long, which probably match both.
Yeah.
Okay, so we can search for both clauses in there. So we've had a look at slightly more advanced things with our select statement. We can do removing duplicates. So we've had a look at using that distinct word. Sorting, we've seen actually that's quite important, that we need to make sure that we've got an order by to remove any duplicate, order everything in the correct result set that we want. So if we want it by product ID, we tell it to do it by product ID. Paging, because we might want the top 100 things, but equally we might want the next 100 things. So we can search for blocks within there. And using our where clause as well. So we've got lots of different things we can do with where. We can use like and wildcards. We can do greater than. There's multiple ways we can search through for our data to find the correct results. And always trying to make sure you only present those correct results to the client. You might think, well, there's the correct results and a load more. But remembering that that actually can cost your network and the actual performance of the end product, the website, whatever it's ending up being, will be affected by you moving large amounts of data around that you don't need.
Okay. So, great, thanks for that. That's a fantastic trip through using the select statement, building on what we did in the previous module. Take a look at this video, make sure you're happy with everything in it, and then download the lab files for the course and do the lab for this module, Module 2. And that will give you a chance to get hands-on and try some of this stuff for yourself that we've seen. There's a number of challenges in there where we'll get you to figure out the right Transact SQL to write, and there are solution files for you to check that your answers are correct. When you've done that and you're comfortable that you're ready to move on, join us for the next module when we'll look at starting to work with multiple tables.